Welcome back to the Metal 52 workshop, everybody. I hope you enjoy this episode. For this next project, it's just a small thing, but I wanted to replace my cylinder cocks on the Allen Mogul. And the existing ones, I'll show you them in a second, but it's a really clever design, honestly, that I made them myself. The problem is they've never really worked right. But they screw into, there's a thing that screws into the bottom of the cylinder, and then there's a little ramp that comes in. There's a rod and a ball bearing, and it's a clever design, like I said, but for some odd reason mine have never worked perfectly. So I want to replace them with these ones I got from Reeves 2000 in England. It was less than $100 for the set, even with the VAT and the postage, so airmailed to me in the United States. So, I mean, I like making fittings myself, but for that price, it was a bargain. Keith Appleton has some good videos on these, and he points out that they're handed, so they're in pairs. You know, one set will be right hand and the other set will be left hand. He also points out a clever idea for putting something in there. He used glass-headed pins to mark the open position. So as you can see, I've got a little 080 brass screw in there right now, brass machine screw. Let me walk you around and show you. So here's the Allen Mogul. Here's the existing thing. I've been playing around with it a little bit. I have a lever here that actuates the cylinder drains, cylinder cocks. So forward is closed right now and back is open. And I'll leave it that way for a minute, and I'll walk around and let me show you the design. Okay, here's the cylinder drains. Like I said, I made these myself, and they kind of work. You know, perfectly honest, it's on me that they don't work better. But it's a little brass bar, and it has a notch cut out of it, and there's a ramp, and when the ramp is high, it pushes a pin up and which pushes the little ball bearing up, and it allows steam to come out. So that's the steam and water. That's the open position. So it's open right now. In the down position, let me push this like that. So the ball falls down, or excuse me, the pin falls down, the ball falls down, and the steam pressure inside the cylinder closes it. So that's the closed position right here, if you can see that. But like I said, maybe how I cut these ramps or whatever, but it just doesn't work that great. The actuating mechanism is very simple. Just a rod here that rotates back and forth, and a little lock and a tab here. Let me show you the other side. Here you can see the reach rod from the cab comes, and it just simply actuates this arm. Very simple mechanism. Here's the ones on the other side. So these are the ones I want to replace with the fancy store-bought, and that's what we'll be working on in this episode. Alright, I've got some air in the tank here. I wanted to show you the cylinder drains. They're open. This one is open, this one is not. We put it to the closed position. This one stays open even in the closed. I can feel it. So, just wanted to demonstrate. Before we get deeply into the project with the cylinder drains, I wanted to point out something. This is going to be a little hard to see. Let me get the flashlight. But when I was test running it last night to illustrate how the cylinder drains don't work properly, and it's, you know, it's my fault the way I built them. But the Johnson bar jammed, and I couldn't figure out what was wrong with it. It was hard to see in the dark. Luckily, I had the day off today from work, and I could get out here in the daylight, and I found that what happened, that screw that I'm shining the light on there, the nut fell off of it, obviously. And luckily, I saved the construction plans here. This is the special bolt that I made myself out of 1/2-inch steel, and it's a 1032 thread. So it was 2013 when I made this, so it's been 12 years since I made that part. I'm glad I found it and figured out what the problem is. So obviously, what the frustrating part was that the bolt was not sticking out like it is now. I had to actually get basically some tweezers or some hemostats there and twist it out. So luckily I've got it out, and then I repositioned the Johnson bar so that the other side of the nut, there's something backing it, or the other side of the bolt, the head of the bolt area. So now I'm gonna put this back on with at least a new nut and some red Loctite, and I'm going to see, hopefully I've got enough room there for a lock washer also. So that's going to go back on, and I'm going to go around and check all the other teeny tiny little parts, cotter keys, everything else like that I built 10 or 12 years ago. And so it's a good lesson. Nothing broke, didn't hurt anything, thank goodness. But I wanted to just point that out. And then we'll take care of that first, and then we'll get on with this. Okay, happily I found a place I could put my little flashlight so that it sits still, and I've slipped the lock washer on there, and it looks like I've got enough threads for the nut to go on. I'm going to put some red Loctite on it anyway before I start threading it on. And even though this is Russ's camera, I don't have the stand. There's no place to put the stand for it here, so I'm just going to do this off. Alright, hallelujah. I used the nut driver there and was able to get it on. You can see there's a little surplus red Loctite on there, but it's on just snug enough that hopefully between the lock washer and the Loctite it's not going anywhere. So now I can go around. You can see I've got cotter keys on a lot of key places, and I know I put this together right. You know what I'll do? This is a cool thing about YouTube. I couldn't remember what all these pieces looked like because this is the first locomotive I ever built. So I found a video that I posted on YouTube that showed this exact assembly before I added the rest of the locomotive. So I'll put a link to that in the description or in one of the comments to this video. Hopefully that's helpful. It's cool. I still see like some of my notes here I wrote right on this one, and you can see where we did the timing. Fred V came over and did the timing for me, and some of the original marks are still left on the wheels, so because obviously I haven't run it that much, and that's hopefully going to change next year. Alright, enough with that, and we'll get on with the cylinder drains. I've just removed the little screws here on either side that hold the actuating lever to the rod that slides back and forth that is supposed to open and close the steam valves. So I just wanted to take a picture of that. The other consideration, you know, it's not rocket science, but I will have to build out, since this rod, this actuating lever is geared to the center line of the valves, and obviously the little valves that I bought, the lever is on the outside, so I will have to build up, you know, somehow match that lever. So just wanted to point that out so you can see. This is a nice picture. There's an actuating lever that goes underneath, and it's similar to the Johnson bar, the little setup. It's just a straight rod that goes back and forth, and obviously I can move, when I move it back and forth, I've got set screws here and on this, and it just rotates that bar, which opens and moves the actuating arms like they're supposed to. So not a big deal. Next step, for now that I've got these screws and the nuts and bolts taken out, I'll remove these cotter keys, and then one by one I can take the bar out, and the little rod will come out as well. So I'll get that done next. I got the brass sliding bar out. You can see the shape of it, and it was covered with oil, so the good news is the cylinders are getting plenty of oil. The other interesting thing is that the rods are stuck in there. I was expecting them to drop right out once I removed the cotter keys here and the ramps. So they didn't come out, so no worry. Oh, actually, look at that. There's one of them. That's the rear one. A tiny little brass bar, so it did come out eventually. I don't know where the front one is, but anyway, now I'm going to use a couple of small wrenches here to take this out, because I'm going to keep the top fitting in, and this fitting here, the good news for me is the top of these lower fittings are tapped and threaded, are threaded 1/4 by 40, so that should be a perfect fit. In essence, these top parts will act as an adapter for the ones that the store-bought cylinder drains. So now I'm just simply going to take this out. I'll use this wrench to hold the top one steady, and this larger ignition wrench, 3/8 inch ignition wrench, to remove the bottom part. I'll do that off camera. I removed the bottom parts of the cylinder drains from both locations, and just wanted to show how this is supposed to work. So both of them, you can see there's the little stainless steel ball, and the rod that's in there, when you activate the ramp, it pushes up on the stainless steel ball, and then it's supposed to let the excess moisture go out. And then of course when you close it and you bring the ramp to the lower thing, then the rod falls down, and the steam is supposed to seal the hole. So clever design, just obviously my mistake at how it didn't work. But I wanted to show this little hole in the side here. This is the actual outlet drain here for the steam to come out right there. If you can, hopefully that shows up where the pick is going in. So it is definitely a good design. I'm going to save all these parts just in case my new things don't work. I'll put all these in a little plastic baggie, and I can clean them and maybe reuse them if I need to. The 1/4 by 40 stems on the parts that I took out were a lot shorter than these, so I ended up using some giant washers. Actually used some automotive type 1/4 inch copper washers, and then I used the tiny ones from Reeves 2000 here to get the exact right fitting. But I got them nice and tight now, and they're oriented like they need to be. So that side's done. And one more thing, speaking of the 1/4 by 40 threads on these, it was real tight. It didn't want to go in, so I actually have had to manually thread just to kind of reduce the size of the threaded end here. I was going to show you, well, it's a little bit, just almost like chasing the threads just one time, and it reduced it enough so that it screws in there just fine. So that part was a lesson learned. So now off to the other side. My goal is to get both the new cylinder drains installed in both sides with the washer spacing and everything, get that done tonight, and I can come back tomorrow or when. Alright, so here we have it. Got the right side installed. It was a little easier since I didn't have to do the filing on the shoulder, but I did use the large automobile copper washers. 2 of them here did the trick, and then a combination of the large and small on the back. So again, got it all lined up nice. Now I can start playing with templates for, just a connecting rod, and preparing to make the connecting rod there. First of all, I moved the lever arm so that the control is in the rearmost position, which matches up. So these are in the open position now. I don't know if you can see, but I put a little piece of masking tape on the bottom of each one of these, and that's holding in a 080 brass bolt to ensure that I've got the cylinder drains fully open. Just you can see the vertical stripes there, so they're fully open. I know it. I've got a little machine screw taped inside there, and now the main point is I just wanted to measure to confirm. I had measured 3 3/8 of an inch between centers before, and sure enough that's still the same. So I'm going to go with that. I'm going to take a piece of wood and make two like 1/16 inch holes that are 3 3/8 inches apart, and I'll make it long enough. Let's say so about, it needs to be about 5, not quite 5 inches long, but I can make it, and so there's long enough that it'll extend past the front groove. So I've got something here. My idea is just something like a long popsicle stick basically, and then I'll see where the front of this is. Then all I've got to do is measure where the front hole needs to be and figure out the spacing in between the connecting rod and the actuating arm, and decide whether I want to make a bend or put a spacer in there or whatever. So one step at a time, getting the distance, making a rod. Here's a little wooden template that I made. Not much to it, like I said, a lot like a popsicle stick, but I just drilled a 1/4 inch in from the back. I drilled a little 1/16 inch diameter hole, and then 3 3/8 inch separated. I drilled another one, and I was able to test fit them. Watch how nicely this fits on here. So it fits on there great, and now I can test and see the movement. This is all the way open back here, and then closed is just going to be like this. So I was able to measure, take the ruler, mark the vertical line that intersects the front hole in the actuating arm, and also measure the back spacing, if you will, which is about 5/16 of an inch. So now I can think about how I want to accomplish, bridging this gap, making bending a piece of brass this way. I took off both of the little wooden blocks, and they are identical, and I think it's going to give me a good fit. The measurements are identical, so I laid out, here's a little pattern about a 1/4 inch in from the back, and 3 5/8, and then another hole at 4 5/8. That'll be for the connection to the linkage. And I laid that out on this piece of 1/16 inch brass, which interestingly enough is the exact brass you can see by the end pieces. That's the same piece of brass stock that I cut my original ramps out of. So I know it'll be sturdy enough, especially since it's basically, they're just 1/4 inch long, or 1/4 inch wide by 5 inches long. And yes, they are opposite each other, but since they're identical, I can drill all the holes from one side, and I'll just obviously flip it over. Okay, here's the finished, well, the slots are cut anyway, so pretty pleased with how that came out. Not going to be a lot of file work to do, so I can take them out, file them, cut them in half, bend them, and then test fit them. So that'll be exciting to see. I'll bring you along for the next couple of steps. So here we've got the part. I'm filing it. Let me turn it around so you can see some of the outlines. Just using the tiny Riffler files, these little ones. I think I got these from Harbor Freight, not sure. Certainly wouldn't be surprised. But I'm just filing smooth the edges of that 70 thou thick slot where the number 256 screw is going to hopefully slide and give us the variable geometry we need to activate the. I'm glad I checked with the screw here. I've got the little number 256 screw, it held in a little forceps, and now you can see, hopefully you can see that, plenty of free travel. I did the sides with the flat tiny file, and I did the ends with a small round file, just to make sure it's a smooth surface that nothing the screw could catch on. So now we've got that accomplished. Now we can cut the two pieces in two, and then do the bending. Well, I've got the new parts finished here. I'll hold them up in pairs so you can see the difference between the original and the new elongated one, with the hole that hopefully the screw will slide in, and like I said, that'll give us enough movement. It's 3/8 inch long overall hole, sliding hole, and that basically, otherwise the geometry is basically the same. The only difference you may notice excuse me, is that I made the top part smaller on for the large. Alright, I've got the left side installed, and you can see the handle is all the way forward, so the lever is all the way backward, which is in the closed position. And if I rotate it forward, it does travel all the way forward for it to open the cylinders. So looks like it's going to work. And it's funny, there's not nearly as much vertical travel as I thought there would be on this. I wonder if I should loosen this screw up just a teeny bit. It's not really very tight. Wrench. Go ahead and do that. Still the wrong wrench. Forgot it's the tiniest one. There we go. Okay, it's a half. But you can see it. I mean, I don't know if it comes across in the video, but it's very free now. You definitely feel a binding before. So just that little bit, just allowing that screw to travel up and down, that's all it took. So I also did have, I don't know if you can see this or not, but I did have to cut. Time for a little test. I've got the air compressor hooked up, and locomotive is ready to go. So let me put it in forward. We can check how the Johnson bar is moving. And the cylinder drains are open now. Here's the action there, if you can see them down there. They're in the open position, so let's give it a little throttle. And you can see that. Check these. Okay. Definitely open. Let's try closing them. It's closed. Definitely closed, so that works good. You get a little more air pressure here. Now let's try moving it to reverse. There we go. Alright, everything checks out. Very happy with that, and appreciate you being part of this test. So I'm going to leave this run so it can run all the way out. If you enjoyed this, please give me a thumbs up. If you have any questions, please ask. And I look forward to seeing you on the next one. I got some cool stuff planned. So thanks, and have a great week, everybody.